You know how companies like Uber can track cars in real time? Or how a stock app can process thousands of trades every single second? It all comes down to managing this constant, kind of overwhelming flood of data. And that's exactly where AWS Kinesis comes in. It's built to tame that flood. So let's dive in and see how it all works. Here's what we're going to cover. First, we'll talk about what streaming data actually is. Then we'll meet the Kinesis family, follow the data's journey from start to finish, check out some really cool real-world examples, and finally, lock in the most important takeaways for you. All right, let's kick things off with data in constant motion. Before we can even get into the solution, we've got to understand the problem it was built to solve. So what exactly is streaming data? Well, it's all about information that just never stops coming. So, what are we talking about here? This isn't about big, static files you download once. Nope. I want you to think of a constant river of tiny little data packets. It's the clickstream data from a website, it's telemetry from a sensor in a smart factory, or location updates from a delivery app. It's small, it's super fast, and it is relentless. And that leads us right to the big challenge, doesn't it? When you have literally thousands of sources all sending you information at the same time, how on earth do you collect, process, and analyze it on the fly? You can't just save it to a database and look at it tomorrow. The real value is in what's happening right now. And this is where the name is just so perfect. Kinesis is actually a Greek word that means movement or motion. Amazon picked it for a reason, because the entire service is designed from the ground up to handle data that is constantly moving. That one idea, data in motion, is really the key to understanding everything else about it. Okay, so now that we get the name, let's meet the Kinesis family. You see, Kinesis isn't just one single tool. It's actually a suite of services built for different kinds of streaming data. We're going to focus on the two main ones. On one side, you have Kinesis Data Streams. This is your go-to workhorse for all that non-video data we were just talking about. Logs, sensor readings, financial transactions. And on the other side, you have Kinesis Video Streams, which is purpose-built for, you guessed it, video. From security cameras, body cams, you name it. It's the same core concept, just for different types of data. All right, so how does this whole thing work under the hood? This is where it gets really interesting. Let's follow a single piece of data on its journey through the 4 key stages of a Kinesis data stream. So everything starts with what we call producers. These are just your sources of data. It could be your phone sending its GPS coordinates, a smart thermostat pinging the temperature, or an application on a server sending log files. They are constantly just creating and sending these little data records into the system. Next up, all of that data flows into the Kinesis stream itself, and this is where the magic really begins. The stream isn't just some chaotic data dump. It's a super organized structure made up of things called shards. So what in the world is a shard? You know what? The best way to think about it is like a single lane on a huge data highway. Each shard takes the data records that flow into it and keeps them in a strict, ordered line. The more shards you add, the more lanes you open up on your highway, which means you can process way more data at once. This is the secret to how Kinesis scales. And here's another really important feature: durability. The data doesn't just disappear after it's been read. By default, it's held safely in those shards for a full 24 hours, which gives your applications plenty of time to process it. And if you need more time, you can even extend that retention all the way up to a full year. Okay, so the data is in the stream, it's organized, it's safe. Now it's ready for the consumers. These are the applications that connect to the stream, pull that data from the shards, and actually do something useful with it. They might be running sentiment analysis on a live Twitter feed or calculating real-time stats for a video game. And finally, after the consumers have worked their magic, the processed data, the actual valuable insights, is sent to its final destination. This could be cheap, long-term storage in Amazon S3, a super-fast DynamoDB database, or even a data warehouse like Redshift for more business intelligence down the road. All right, so that's the architecture. But what does this actually look like out in the wild? Let's check out how this powerful tool is being used every single day. The real-world applications are just incredible. We're talking about high-frequency stock trading, where every millisecond counts. Game developers analyzing player behavior as it's happening to make the game better. Companies tracking brand sentiment on social media. Ride-sharing apps pinpointing car locations. Smart factories monitoring your equipment. Even e-commerce sites giving you recommendations based on what you are clicking on right now. The possibilities are just so diverse. Okay, let's bring it all home. We're going to boil this all down to the absolute essentials. So if you're studying for a certification or just want to make sure the core concepts stick, this is for you.
Let's recap. First, Kinesis is all about real-time streaming data. Just remember that Greek word for motion. Second, always remember the difference. Data streams is for general data, video streams is for video. Simple. Third, a stream is made of shards, and those shards are what keep the data in order. And finally, you have to know that core data flow. It goes from producers, through the stream, to consumers, and then on to its final destination.
And that's a wrap on our Kinesis explainer. We've seen how it takes on that huge challenge of continuous data. So I'll just leave you with this question to think about. Now that you know how to manage data in motion, what real-time problem would you want to solve first? The possibilities, as you can see, are pretty much endless.